Good morning students. Today we are going to discuss lesson 3, magnetism and magnetic effect of electric current. What is our lesson? Magnetism and magnetic effect of electric current. In this lesson, in our previous class we have discussed a number of topics, isn't it? Today we are going to discuss an important topic, cyclotron. It is a 5 mark level question and 2 mark level question. How that if totally asked 5 mark level condition, what is the condition to accelerate cyclotron, that is our advantage and disadvantage of cyclotron, that is 2 mark level question, and formulas based problem will come. Okay, it is final formula, use that formula to solve the problems. So we are going to discuss now cyclotron. Cyclotron is a device is used to accelerate charged particle to gain large kinetic energy. What is that? It is a device. See that? It is a device. Cyclotron is a device. This device used to accelerate. What to accelerate means charged particle. Example of charged particle: proton, new electron, etc. are the charged particle. So it is cyclotron is a device used to accelerate charged particle into gain. That charged particle gain large kinetic energy. What is that? It gain after the acceleration. This charged particle gain large kinetic energy, or I large kinetic energy. See that K dot means kinetic energy, large kinetic energy. This device is also called high energy accelerator. What is that? One more question. High energy accelerator. High energy accelerator. Which of the following device? How they will ask one more question. Which of the following device called high energy accelerator? Cyclotron. This device was devised by two scientists. One is Lawrence and other one is Livingston. Which is the year? 1934. One more question this is also. So cyclotron is a device. It accelerates charged particle to gain large kinetic energy. This device also called as high energy accelerator. And the device was devised by Lawrence and Livingston in the year 1934. This is the introduction of cyclotron. Next, what is the principle of cyclotron? One mark question, and sometimes they will ask 2 mark also. What is the principle of cyclotron? When the charged particle move normal to the magnetic field. What is that? Charged particle move normal or perpendicular to the magnetic field. Already we have discussed in our previous class, any charged particle move perpendicular to the magnetic field or normal to the magnetic field, they experience, what they experience? Magnetic Lorentz force. Magnetic field produces or experiences the magnetic Lorentz force. So don't consider M dot L. This is magnetic Lorentz force. This is the principle of cyclotron. What is the principle of cyclotron? Means charged particle move normal to the magnetic field. After that, the charged particle experience a force. That is what force means? Magnetic Lorentz force. We are detailedly discussed in our previous class what is magnetic Lorentz force. Okay. So this is the principle. Sometimes the principle alone they will ask what is the principle of cyclotron. Okay. So charged particle move normal to the magnetic field, then experience magnetic Lorentz force. Next, construction. What is that? Construction of cyclotron. The schematic diagram. See that first I will draw the diagram. Otherwise I will explain. the schematic diagram of cyclotron. See the board. So it consists when the charged particle allowed to move between the metal circular plates, or it is called Ds. See that? First I will draw the circular, semicircular Ds, semicircular metal plates. The semicircular metal plates also called as D. So the charged particle allowed to move the semicircular metal plates called Ds. We call as this is D1 and this is what is the D2. D is called D1, D2. So the schematic diagram of cyclotron, see the diagram. When the charged particle allowed to move between the Ds. The Ds, how that means, it is nothing but metal circular, semicircular plates. The semicircular plates are called Ds. The Ds are kept are placed between the evacuated chamber. Evacuated chamber. See that? Assume that this is like evacuated chamber. In that evacuated chamber, they maintain the uniform magnetic field. How that maintaining uniform magnetic field? Uses of electromagnet. See that? This is north pole and south pole. So this is called electromagnets, north pole and south pole. The electromagnet, the electromagnet provided the magnetic field. That magnetic field, how that means uniform. See, these lines are, what is that means? The lines are called magnetic fields. So once again, it consists of, that means the schematic diagram consists of two semicircular metal plates. They are called Ds. The Ds are placed in this is a evacuated chamber. Evacuated chamber. In that evacuated chamber maintaining the uniform magnetic field. How means? By the electromagnet. The electromagnet north and south pole, that maintaining the uniform magnetic field. How that uniform magnetic field means? These uniform magnetic fields are perpendicular or normal to the plane of the Ds. How that magnetic field here acting, providing the electromagnetic field, the magnetic field is perpendicular to the uniform. How that perpendicular to the Ds. And these end of the Ds, see that these are the ends. The ends of the Ds are connected by high frequency alternating potential. See that? Or high frequency oscillator. The ends of the Ds are connected by, see that? This is the ends. The ends of the Ds are, this is called high frequency alternating potential. The ends of the Ds are connected high frequency alternating potential. Okay. So once again I will explain construction. Clearly, carefully watch. It consists of two semicircular metal plates called as Ds. The Ds are separated, are kept in the evacuated chamber. Why we are kept in the evacuated chamber means this evacuated chamber maintaining the uniform magnetic field by the use of electromagnet. These electromagnet providing the magnetic fields are perpendicular. Now the ends of the Ds are connected by the high frequency oscillator or alternating potential, and upper end is connected by the deflecting plate. I will explain why we are, this is called deflecting plate. Deflecting plate 1 and plate 2. See that? This is the deflecting plate. Or when the, where we have to keep that particle means here, the center of the gap. Next, working. We have to assume, what we have to assume means the ion is ejected. What here ion called maybe particles are the ions. ions are ejected by the source. The source is, how that means, positively charged. Positively charged. See that? Assume ions are ejected by the source. Where that ion we are kept means, we are kept the ion between the gap of these. Source are kept between the gap of these. Because these are initially separated small gap. What is the purpose? They are separated small gap means because we have to keep the source between the gap. That's why the ions, these are kept initially separated. So source are kept between the gap of the D's. Between the gap of the D's. Now the ion is the source ejected ion accelerate. Source ejected or eject the ion. Ion means here what is represented by charged particle. What is that? Charged particle. Charged particle. This charged particle is the ion. That charged particle accelerates towards the D1. Towards the D1. How that means? See that? This is the source. The source ejected the ion. The ion moved to enter into the D. At that time, the ion, what is that? The ion is negative. Important one more question. Negative potential. What is the potential of ion when the ion enters the D1? That time the ion is negative potential. When the D's are having magnetic field, isn't it? The D's, the D1 having the magnetic field, isn't it? Here magnetic field is there. No, due to the magnetic field, what happened? The ion, due to the magnetic field, the ion move circular pattern, but the D is, what is that? The D1 is semicircular. Semicircular. So due to the semicircular, what happened means it completes the semicircular. It comes and it enter into it comes the gap. What happens means the particle not to move. That means it arrives in the gap. They are not able to move another D's. Once again they are accelerate. Once again, so the ions are arrive near the gap stops. Arrive the gap, what happened? The particle once again, here particle means ions. Once again we can accelerate. Once again what we have to do? Accelerate. Once again accelerate with the greater potential. See, once again, after construction we are going to discuss working. when we have to assume the source ejected ions are ejected by the source are positively charged. The source are kept between the gap of the D's. The source ejects the ion, that means charged particle, we can accelerate. Where we have to accelerate? Towards the D1. The ion is in the undertone, the ion is negative potential. The D1 having the magnetic field. Due to the magnetic field, what happened? Ion in the circular path. But the D is semicircle, so the ion arrive the gap. That means semicircular gap. Here it enters the gap, stops that. So once again we can accelerate the particle ions. Once again we can accelerate. What happened? The particle enter into other D, but change the potential. The ions enter D2, change the potential. So initially we are taken negative potential, isn't it? Now what is the change in potential means? Now the ion is what is potential? What is the potential is positive potential. What is that? The potential is considered to be positive. That is positive. So it move into the other D and complete the one more semicircle and enter into the arrive the gap, stop. Once again we can accelerate. It move into the D1. What happened means it change the potential. What is the potential now? D1 means negative, D2 means positive, and move into the D1 and comes into the gap. Once again we can accelerate, enter into the D2, change the potential. The experiment is repeated, that means the ions are continuously moving and complete the semicircular path. See that? And complete the semicircular path, and it is assumed as a spiral. Look at the diagram. It assumes what is that? Spiral. And the ions are comes at the edge of the D's. The ions collected by the deflecting plate, where we have to collect. See, it comes here. We are collected by this deflecting plate. This is the deflecting plate, and getting the deflecting plate, the ions are collected by the deflecting plate. After that, collected the deflecting plate, we have to hit to the target. They are producing high kinetic energy. See that? Charged particle move normal to the magnetic field, they experience magnetic Lorentz force. So the ions are enter the D2, change the potential, that is positive. So what happens means the ions complete the spiral path. The ions. So what happens means after spiral path, when the experiment is repeated continuously, it the velocity of the ions increases, radius of the ion also increases. What happened? The velocity in each, if move into the each D's, the velocity of the ion increases. Due to the increase the velocity, radius also increases. First spiral, second spiral, third spiral. When it is comes to the end, the ions comes to the edge of the D's. These collected, the ions are collected by the deflecting plate, DP, called deflecting plate, and hit to the target. They give high energy or give that large kinetic energy. What is that? Large kinetic energy. So when we derive the mathematical expression, so very simple, the working. Once again I will explain working. Suppose we have to assume the source ejected by the ion, that is positively charged. The source are kept between the D's. When the source ejected ion, the charged particle move towards the D, we have to accelerate. the ions are negative potential initial action when you enter in the D1 initially. So due to the magnetic field in the D's, they are moving the circular path, but D is spiral, semicircular, no. So it comes into the edge of the D's, that means arrives in the gap, it stops the ion, acceleration stops. Once again we have to accelerate to move into the another D. What happened? They change the potential and make to move into the another circular path. It comes into the gap, once again stop, once again we have to accelerate. We have to continuously do that, repeat the experiment. When the particle continuously moving and comes into the near edge of the D's, we have to collect with the deflecting plate and hit to the target. They give high or large kinetic energy. Now we have to deduce the mathematical expression. Due to the circular path, that means they providing the centripetal force, magnetic Lorentz force providing the centripetal force. See that centripetal force mv square by r, isn't it? Magnetic Lorentz force bqv. Here v cancel, rest of them mv by r equal to bq. Our aim is to find r equal to mv by bq. What is that? mv by. Otherwise r, this equation I want to write that other format. Just very simple. See, r equal to m by bq into v. That equation, this is equation number 1, r directly proportional to v. This is equation number 2. This equation number 2, if radius increases, velocity of the particle also increases. If velocity increases, radius also increases. How that velocity and radius increases? I will draw once again the diagram how the particle, the charged particle, velocity increases, radius increases. See that? Assume this is D1, this is D. Suppose this is high energy already potential. No, your deflecting plate dP is there. Assume in between here, what is there? Magnetic field. How that magnetic field means perpendicular to the plane of the piece. This is V1 and this is what is that? D2. This is the source, isn't it? When the source ejects the ion, this is the ion. This dotted point is called ion. This is source. The arrow mark here, dotted point. We have to accelerate. Here we can accelerate. After the acceleration, the particle enter into the D1. What is there in the D1? Having the magnetic field, isn't it? So due to the magnetic field, the particle move into the circular path. But the D has, which is the same, semicircular. After the semicircle, it comes arrive in the gap. Once again, it is moving into the gap. The particle will not move. Once again, we can accelerate. So what is the entering time, the potential? Suppose the negative potential means if we enter into the gap, it stops the acceleration. Once again we can accelerate and move, enter into the other D. What is the potential? Potential of the particle is changed. Now positive potential. It move and complete the semicircle and enter the gap. Once again we can accelerate. We have to with the greater velocity. So what happens means the particle enter into the D. So radius increases, velocity increases, radius also increases. See, once again accelerate. See that if velocity increases, radius of the ion also increases. Initially, complete looks like spiral. So each circle radius increases. No, so velocity, the equation to represent radius increases, velocity of the particle also increases, or velocity increases. See, it comes to the near of the edge of the D's. We have to this ion is collected by the dP and hit to the. This is the final. They give large kinetic energy. Hit to the target, give that large kinetic energy. Initially, suppose you have to assume this is the radius. And every time R1, R2, R3 radius increases, R4, R5 the radius increases. See that when the velocity increases, radius also increases. Next, so equation 2, important one mark question. Radius of the ion directly proportional to velocity, or velocity of the ion is directly proportional to radius. Okay. So next we are going to the one important condition of cyclotron operation is frequency, resonance condition. Important condition of oscillator cyclotron operation is what is the resonance condition. The ions having the positive potential, otherwise the ions we are considering the ions having the frequency, the ions having the frequency f, the ions having the frequency f, that means particular frequency of the circulating to the frequency of the circulating what ions? Positive ions. Circulating positive ions to the magnetic field. That is equal to the constant frequency of the electromagnetic or circular oscillator, electrical oscillator. Constant equal to the constant frequency of the, what is that means? Electrical oscillator. So this is a very important point. The important condition of cyclotron operation is resonance condition. What is resonance condition? The ions having the frequency, that frequency of to the circulating positive ions, the positive ions to the magnetic field, that is equal to the constant frequency of the electrical oscillator. See that? Oscillator frequency BQ we already discussed, BQ by 2 pi m. In our previous class, how we got it F also. So time period T is equal to 1 by frequency of oscillator. Equation 3, equation 4. Substitute equation 3 in equation, so I have this one. Substitute equation 3 in equation 4. What you will get? Time period equal to 1 divided by oscillator frequency. What is oscillator frequency? BQ divided by 2 pi m. This denominator going to be numerator. So time period 2 pi m divided by BQ. So this is equation number 5. This equation number 5 is evident. Time period is directly proportional to mass of the particle and inversely proportional to magnetic field and charge. What is that? Charge. Time period directly proportional to mass of the particle, and the same time period is inversely proportional to magnetic field, then charge, but independent of radius and velocity. What is that? Time period is directly proportional to mass and magnetic field, charge of the particle, independent of, already in our previous class we discussed radius and velocity. Now we have to find out kinetic energy. So K equal to mv square, basic formula. From that equation number 1, we have to convert it into the velocity. So V equal to BQ R divided by m, isn't it? So now we have to substitute here this. So what we will get? Of m, there is no change. What is V square? We got it V. So V square, instead of substitute V, so B square Q square R square divided by m square. denominator. So here m square in the numerator, m cancel. Rest of the term, what is the kinetic energy? So kinetic energy of the particle is numerator b square q square r square denominator 2m. This is our required equation number. Our last equation is 5, so equation 6. This is the kinetic energy provided by the particle using the particle in the cyclotron. Next, we are going to discuss a very important 2 mark, sometimes they will ask 3 limitations of cyclotron. Limitations of. So first point, cyclotron cannot accelerate electron. Cyclotron cannot accelerate the electrons. Important number. Which of the following particles cyclotron cannot accelerate electrons? And uncharged particle also cannot be accelerated. Cyclotron cannot accelerate uncharged particle. So cyclotron cannot be accelerated. Cannot accelerate uncharged particle, cannot accelerate the electrons, cannot accelerate that means cyclotron cannot accelerate the uncharged particle. The speed is limited. What is that? Another point. The speed of the ion is limited. Here, the cyclotron, the device providing speed, the speed of ion is limited. So maximum number of time, the limitations of cyclotron asked 2 mark level question. And sometimes they will ask, suppose they will ask 5 mark question, we will start introduction, principle, construction, working, then limitation. You have to write, then you will get in the, what is that, 5 mark. Suppose 3 mark question, write the limitations of only write the limitations of the cyclotron. State the principle of cyclotron. What is the principle of cyclotron? When the charged particle move normal to the magnetic field, it experiences magnetic Lorentz force. That is the principle of cyclotron. What are the limitations? Cyclotron cannot accelerate the electron. Cyclotron cannot accelerate the charged particle. The speed of the ion in the cyclotron providing is limited. That means their speed becomes always limited. This is a very important question using this kinetic energy equation and time period equation and velocity radius equation. When here one important point, radius increases velocity, that means velocity of the particle increases, radius also increases. How increased? I showed that diagram. If you have any doubt, please ask that. Thank you.